See, today we will start the physics chapter, that is first chapter of your science, light, reflection and refraction. Okay, so this chapter is all about what is light, then what is reflections, some laws are there, then mirrors are there. These all things we will see in this chapter. Okay. Anyone can define what actually this light is? Anyone? Like what is light? If anyone will ask the definition of light, what you will explain for this light?
Sir, about the reflection of light, sir.
If light is a reflection or refraction.
No, just light. I am asking about the
It's a-
definition of light, not reflection, not refraction. Ruba Dinesh, my sound is clear now?
Sir. Hi, sir.
Switch on your cameras.
Sir, some network problem. Sir, I switch off the camera.
Okay. I am asking that can you define light? What actually this light is? The simple definition of light, just say.
Sir, form of energy.
See, light means it is a form of energy. Okay, it is a form of energy that enables us to see things. Like we are able to see anything. That is because of light. If you will go in a dark room, you can't see anything. Why? Because light is not there. Okay, it is a form of energy that enables us to see the things. Okay, this you have to mention. It is a form of energy. So there are some natures of light, like everything in this world having a nature or a character, you can say. So like that only the light is also having some nature. So light will behave as a ray. Ray means you can see, like in your textbook also it's written there, incident ray, reflected ray, refracted ray. So these are what? These are the natures of light. Like it will behave as a ray. Okay, example you can see on the screen, reflection is given. Then the next you can say the nature is it will behave as a wave. Okay, like if you will throw a stone inside the water, it will form a wave on the surface of water. Like that only you can see the nature of light, that it will behave as a wave. In the second figure, in diagram you can see this where it's a wave, it is written. Just like say the light will behave as this. Okay. Next is the particle. Like you can say light is made up of the particles. What are these particles actually? These particles, you can say it as a photon. Like the name is given for these particles. You can see in the diagram here, particle, it is written here. And the particle will be like this. Okay. So these are the three natures of the light that you can say. Or you can say the characteristics of the light. It will behave as a ray. It will have a character of a wave also. Then particles also. Okay. Any doubt in this?
No, sir.
No, sir.
So just write the things, like not whole thing, definition of light. And in that one line is written, Maxwell predicts that magnetic and electric field travels in the form of wave. And these waves move at the speed of light. This led Maxwell to predict that light itself was carried by electromagnetic waves, which means that light is a form of electromagnetic radiations. Like one scientist was there, he predicted that light is acting as or it is a form of electromagnetic radiations. What is the meaning of this electromagnetic radiations? Means It is a form of radiation in which electric field will also there and the magnetic field also there. Okay. So just write this two things. The first definition and second this scientist name, whatever he predicted, that you have to write. And the third, you have to write the natures of the light.
Done, sir.
See, these are some words that it's given there: interference, diffraction, photoelectric effect. We will see in the chapter only. Like first, we will go from the basic, then we will see these things. Okay, if I will explain you now, you will get totally confused. So the next is, you can see, according to the concept of wave particle duality in quantum mechanics, light exhibits both particle and wave nature depending upon the circumstances. A phenomena like diffraction, polarization, and interference could be explained by considering light as a wave. A phenomena like photoelectric effect is explained by assuming that light consists of particles called photons. So what basically it is saying in this, light will act as, or light will behave as both particle nature also and the wave nature also. Why we are saying that light will behave as a particle and wave? First, we will talk about particles. Okay. Suppose, see, here I am making some particle. Okay. Or in the previous diagram only you can see. Wait. Here you can see particles. Some dots are there in this light source. So because of that particle only, the light will travel from one position to the other position. If you will suppose if you are in a dark room, okay, and a light is coming from a hole, you can see like a hole is there in or ventilator is there in your room, and your room is completely dark, but the sunlight is coming from that ventilator. In that ventilator the light will pass, and in that light only you can see these particles like nature. Have you ever observed this anywhere in your?
Sir, that
Yes,
light
Aditya, what you are
particles,
saying?
no, sir, light particles get reflected in the moisture in the air, sir.
Sorry, I'm not getting what you are saying. Say again.
Sir, in last year we learned on chemistry, sir,
Yeah.
about light particles getting reflected due to the moisture or the water content present in the air.
Yeah, that is, you can say like that is the reason, but that is not the only reason you can say. Okay.
Oh, okay, sir.
That means that we will consider as whatever you have said, moisture, that is the reason for traveling of light, but particle is also there in that nature. So that's why it is responsible, you can say, for traveling from one place to another. Okay, and wave means in the diagram only you can see it will when you are throwing a stone in a water, it will make the waves on the surface of water. Like that only, we can say the light will behave as a wave. One example, if I will say, you have two torches in your hand, okay, and at a single spot, if the first torch you will on, and that will you just reflect that light on the surface, and you will use the second torch at the same position. So what will happen? The intensity of that intensity of light at that position will increase. It's not like one torch light will block the other torch light. It will not be like that now. So that's why you can say the light will behave as a wave. Understood
Sir,
what I
that
say?
point I can't understand, sir.
See, why I am saying like light will behave as a wave also, like wave is having a nature that it doesn't occupy space. Particles, they can occupy space, but wave cannot occupy space. So one phenomena I am saying to you, you have two torches in your hand. Okay. First torch you are using, and that you are reflecting on a surface of a wall, you can say, at a single spot. Now the second torch, if you will use at the same spot, so the intensity of the light at that point will increase. It's not like one torch light will block the another torch light. It will not be like that now.
So intensity on that closer space will be more.
Yeah, intensity will increase. Suppose in a room you have used only one bulb. Okay, but you can use the second bulb also not to increase the intensity of that light in particular room.
Uh,
Understood what I said? Like if you will use, if you are using only single bulb inside a single room, so that will give you light in that particular space. But if you will use the bulb, second bulb in that single room only, the intensity of light will increase in that room. Same phenomena I am saying here.
so the wall, it will hit the wall, and when the light is placed near the wall, it will hit the wall which is closer, and the light intensity will increase.
Yeah, so that is showing the nature as a wave. That I want to say.
Okay, sir.
Yeah. So in this you write from starting, like according to the concept, this you write.
Completed, sir.
Yeah. See, now some laws are there for reflection of light. Light incident on the surface separating two medias. Okay. So what can happen now when light is traveling from one media to another media? Diagram is there, you can see here. Suppose this is the first diagram. This is the first diagram. You can see when the light is getting incident on a surface. So three things are happening. Okay, like three rays you can see in this figure. Incident ray. So what actually this incident ray is, when a light is moving from the source to a surface. So that ray of light will be known as the incident ray. Okay. If that incident ray will completely bounce back. Here you can see if the light is getting completely bounced back, that ray is known as reflected ray. Here you can see. This is the reflected ray. It means from here the light will come, and from the surface only. It will never enter the surface. It will reflect back from the surface. And that is called the reflected ray. And the third thing you can see here, refracted ray. If the light is incidenting on a surface and it is getting inside the another surface. Here you can see this is air. Here this is
So
water.
refraction happens only in the lens, no, sir?
Sorry?
Refraction happens only in the lens, sir.
In lens means like you are asking the reason where it will happen.
Yeah, that's what, sir. Like it will only happen in lens.
No, it is not like that. If the, you can say refractive index will be different for the two medium.
So that one, the refractive index means one side it is polished and one side it is colored. so it won't be able to pass. In that lens means we both the side will be transparent so that it will pass. So whatever it is transparent on the both side, it will refract, right?
Yeah, you can say like lens is a lens can be.
Water, sir, water.
Sorry, what you are saying, Aditya?
Water will refract also.
Yeah, water will also refract. It is also an example you can say, or you can take as a refracting media.
Okay, sir.
Huh. So here are the three rays that you can see. Like here in the laws, it is written when the light incident on a surface separating two medias, like there air media is there and water media is there. So what will happen? It will get absorbed, it will bounce back, and it will pass through or bend. Three things I have said. Okay, so write these three things. What will happen when the light incident on a surface that is separating two medias?
Sir, but laws of refraction, it is not like this, no, sir.
No, that is also like you can that law I will explain you in next class, like in this class only or next class. This is also there, laws of reflection. Like in your NCRT, it's not there.
Oh, okay, sir.
Okay, sir.
वो वो जब लाइट वाला का थोड़ा सा एनसीईआरटी से डाउनलोड करके भेज दो व्हाट्सएप शेयर कर दो क्योंकि एनसीईआरटी जो पीडीएफ डाउनलोड करता है ना
Done, sir.
कंप्यूटर में ठीक ऑल डन
Done, sir.
कैन आई चेंज द स्क्रीन
Yeah.
this also diagram you just draw okay like the first diagram only you make not the second diagram only first diagram you have to make okay this diagram only
Sir, just the light ray angle alone we can write, no, sir.
angle
Angle, angle, it can be same, sir. Anything.
I'm not getting Aditya what you are saying
No, sir, nothing, sir. Sorry.
Can I change the slide? Done.
Yes.
Yes, sir.
Completed, sir.
Hmm. So now we will see, like, there are some characteristics of light. Again, you can say, like, you know the speed of light, that is 3 into 10 to the power 8 meter per second. So the main law that you have to remember in this, laws of reflection. So what will happen in this laws of reflection? Three lights are there. In this diagram, you can see three lights are there, or three rays are there. First is the incident ray that will come from here, from the source. Second is the reflected ray. Okay, that is means after bouncing back, whatever the ray will be there, that we will call as reflected ray. And this middle portion, that is normal ray. Okay, these all three ray, you can say, will lie at a single point. You can see in the diagram here, all the three lines, all the three lines will lie at a single point only. Aditya, are you there?
Hello.
Yeah, you can listen my sound now.
Hello.
So Aditya, I was saying,
Sir,
like, the
sir,
laws
what
of
is the speed of light, sir? Sir,
like,
what is the speed of light, sir?
speed of light is 3 into 10 to the power 8 meter per second. That is the speed of a light.
Okay,
Okay.
sir.
So I was saying what the laws of reflection. So the first law is
Okay, sir.
three rays. The incident ray, in diagram you can say, reflected ray and the normal ray. The normal ray will be in the middle of this two. All will lie at a single point. Here you can see single point is there. This is the first, you can say. Second, the angle of incidence will be equal to angle of reflection. Means angle I will be equal to angle R. In the diagram, you can see this is the angle of incidence. So what is the angle of incidence means? This is the incident ray.
And that a light is passed, sir.
Sorry, what you said?
The like it is a light past light, sir, from an object.
This,
Angle of incidence.
yeah, in angle of incidence, you will if you have to define, you can say the angle between normal ray and the incident ray. That is the angle of incidence.
Yes, sir.
And second is the angle of reflection, and that reflection angle of reflection you can define it as that you can define as it is the angle between normal ray and the reflected ray. So this two angle will be equal. Angle I will be equal to angle R. Suppose this angle I value is 30 degree. So angle R will also be equal to 30 degree. It's not like it's 25 and it's 20. It will never be like this. Okay, so the two laws that you have to write it here. Just write here laws of reflection. And one
Yes,
single
sir.
line you add there, like before this only, the speed of light is 3 into 10 to the power 8 meter per second.
Sir, when they asked about the speed of light and
Yes, Aditya, what you're saying?
sir, will they ask about the speed of light, sir?
Yeah. Draw this diagram and write laws, okay, and laws of reflection.
One minute, sir.
Done, sir.
Sir, we did not see Fermat's law and all, sir, in school.
So the next is Fermat's principle. So what is this Fermat's principle? This says that light always takes the quickest path between any 2 points. Okay. So rectilinear.
Sir, this they did not teach us, sir.
This is not in your syllabus or what?
Yes, sir. In
Yes,
my
sir.
school, they didn't.
It's not in the NCERT textbook and in our syllabus, sir.
Okay, so we will skip this part. Okay. We will see the like up to reflection of light. We will see the NCRT. Okay.
Okay, sir.
Okay, sir.
Going to light वाला बनाएंगे. One eye and current screen वाला बनाएंगे. Just wait for 2 minutes. I'm sharing the screen. Okay. Hello.
Yes, sir.
Yes, sir.
So screen is visible now.
Yes, sir.
So till now we have
Yes, sir.
read the reflection of light. Two laws are there, that the angle of incidence is equal to the angle of reflection, and second is the incident ray, normal ray, and the reflected ray always lie at the same plane. So the next is spherical mirrors. Like, what are the spherical mirrors? Can you define what is a spherical mirror?
Sir,
Like, in your own word, don't see the textbook.
Sir, spherical mirrors is like a part of a hollow sphere, sir.
Yeah, that you can say. Like, it is a part, you can say, like, not the complete sphere, but one of the part. The
sir,
Yes, sir.
spherical
Because the
mirror,
another part can be like a convex
sir,
and one is a concave.
yeah.
sir, a spherical mirror whose reflecting surface is a part of hollow sphere of a glass. It has two types, that is concave and convex, sir.
Yeah. So a spherical mirror means only whose surface, the reflecting surface will be curved inward or outward. Okay. So two types of surfaces will be there: inward surface and the outward surface. So the name has been given for those particular mirrors. There are two types of mirror: concave and convex. You can see on the screen only concave mirror is there and convex mirror is there. In concave, the reflecting surface, or you can say the curved surface, is in inward. Okay, and in convex, it is just opposite. The reflecting surface will be outward. Understood?
Yes.
Yes,
Yes,
sir.
sir.
So basically, there are some things for this mirrors. Like, they will have uh, center of curvature, focus will be there. Okay, then uh, principal axis will be there. Then pole will be there. Like here in the diagram, you can see this part is pole. Here it will be the focus. Here it will be the center of curvature. So what are these things that we will study now? So first thing that I have said, two types of mirrors are there, concave and convex. Reflecting surface will be invert. See, don't get confused in this reflecting surface. For concave will have a curve invert surface or for reflecting surface, and convex will have a outer surface that will be reflecting surface. Okay.
Okay, sir.
Can you say some examples like where you can see this concave mirror and where you can see this convex mirror? Anyone?
Sir,
So then,
convex mirror is used in
car
the
rear view, sir.
shaving mirror, sir. Shaving mirror,
Rear
sir.
view.
Yeah,
And sir,
In car, it is in the rear view mirror, sir.
so what is this rear view mirror? Concave or convex?
convex, sir.
Ruba Dinesh, you? Any guess?
Sir,
That Aditya said rear view mirrors are the spherical mirrors. But which mirror? Concave or convex?
sir, rear view is a convex mirror.
Sanjeet, you?
Convex, sir.
Yeah, like why we use the convex mirror now? Like it is the convex mirror only in the rear view.
Sir, it
Sir,
reflects
because we need
the,
to
it
see the
bends
larger view of the
back of
vehicles
the
that are
vehicle, sir.
behind the car or
Behind the
bike.
car.
So
Right.
that is one of the major characteristic of a convex mirror, you can say. Like in a small mirror.
Sir, for
Yeah, Sanjeet, say.
sir, sir, concave mirror, it is used the field of solar energy to focus sun ray for eating solar furnace, sir.
Solar furnace, sir.
Yeah.
Furnace.
Concave mirror you can see in the dentist, like dentist used to use this mirror for checking the
Yes,
teeth.
sir.
So that is the concave mirror, you can say.
Yes, sir.
So there are some terms that you have to know for this spherical mirrors. First is the pole. So see here, I am highlighting this part.
Sir, pole is the center of spherical mirror, sir.
This part. The center of reflecting surface is the spherical mirror is a point. Like this is the concave mirror. So this is the center part. Okay. So here you have to denote it
Okay.
as pole, and pole will be written as capital P. Okay, it will be represented by letter capital P. Or here also, if you are using the convex mirror, this is the center part. So here you have to write the pole, like this is the part where the pole is present. Understood?
Sir, are you drawing, sir?
My screen is visible now, Aditya, what I'm saying about the pole.
Sir, you're in that Fermat's principal page only, no, sir?
Yeah, principal, like spherical mirror, 135 page number, I'm there.
No, sir, in the slide what you're showing.
In the slide. The previous one,
Sir, which slide you are showing, sir?
this NCRT I'm showing you, like for this mirror.
Sir, I can only see that Fermat's principle, sir.
Format principle, I think your network problem is there. What you do now, you again join this link, okay?
Okay, sir.
Sir, I had a network issue. I reasoned. What did you say, sir?
See, what you can do, like you can sit near a window, like next class. Try that.
No, sir. Here, no, sir. Today there's a power cut problem in our area, so that.
Ruba Dinesh, for you, the screen is visible.
Sir, I see a Fermat's principle.
Okay, right.
Yes, sir, that only I am also seeing, sir.
Yes, sir. Me too, sir.
Now can you see? Like what I'm changing the slide.
No, sir, only that is visible, sir.
No, sir. No, sir.
Yes, okay. உங்களுக்கு வேணுமா இன்னும்?
Now my screen is changing or what?
Yes, sir, it is changing.
Yes, sir, it is changing, sir.
Now the NCERT page is showing, huh?
Yes, sir.
So what I was talking about, like two types
Yes,
of
sir.
mirrors are there, concave and convex. Okay. So concave mirror will have a reflecting surface and that will be inward. And for convex, it will be outward. Okay. So I was saying about the pole, like where the pole will be there.
Sir, center of spherical mirror. Sir.
Yes, Sanjay, see, here I am saying like this is the center of the mirror. So here the pole will be present. And you have to represent the pole as a capital P. Then for convex,
Yes, sir.
same. This is the center.
It is also at the center.
Yeah. And capital P will be represented as a pole. Okay, here is the center.
Yes, sir.
So next you can say for this the center of curvature. Like what will happen? This is the pole. Wait. Suppose this is a concave mirror that I am drawing here. This is a concave mirror. This line is the center. That is known as principal axis. Okay.
Yes, sir. That imaginary line.
Yeah, the imaginary line, it is known as the principal axis. Here, wherever the cut is there, this part, this you have to represent as capital P. Then, from this pole only, you have to check the length, and somewhere here, you have to write it as a F.
Focal length.
Yeah. This will be the focal length. Next, whatever the length you have taken from P to F now, same length you have to take from F to another line, another point
That
that
is the center of curvature.
yeah, this will be represented as center of curvature and C you have to write it. So these are the things that you have to learn in this spherical mirror. Like after this only you can, there are some diagram that you have to draw. So for that you have to be clear where is principal axis, where is focal length and what is focal length, then center of curvature is there, then pole is there. These things you have to be clear. Okay. So till now you have any doubt regarding the mirror, like up to where I have teached? Laws are there.
No, sir.
No, no, sir.
Long
No,
and
sir.
yes, sir. No, sir. No doubt, sir.
So we will see the next topic in next class, okay? Like I will continue this topic only.
Okay, sir.
So what you have to do as homework, I will ask the things whatever I teach, so that you just go and revise. Understood?
Yes, sir.
Yes, sir.
Yeah. So see you in